very nice introduction to the system dynamics way of thinking, which has been really our basis to develop the values project. So I'm now inviting Benoit. Benoit is a PhD candidate in values. He did huge work in this project, really on the modeling side and in the conceptual development of the model that supported values. And he will tell us what has been done. Please.
Exactly. So hello everybody. So yeah, I'm Benoit, PhD in values, and so here I'm going to present you the model we developed to calculate characterization factors as objective of values, and I will do that with Marco Beyer and Miriam Maschwitz, who are respectively going to talk about pollination and carbon sequestration, and how we assess them and how they are relevant in Luxembourg, and they've been helping us also in the development of the model. So yeah, they will go in the detail of that. Enter. Okay. So first, kind of the methodology, the general methodology we developed, in fact, and followed then on how to assess land use impacts on services in LCA. So if we look what land use is in life cycle assessment, we can see that many different uses are implied in the life cycle of a project, and they can provide many different things. So it can be forests that produce timber for manufacturing tables. It can be dump sites that serve to the disposal of waste. It can be crops that are used as raw materials to produce energy or food. Or it can be factory sites to have a production system. But so what we see is that, so in LCA, as Benedetto said, we tend first to evaluate all of these different demands for land. And but what we see also is that land now is becoming a very scarce resource. Most of the available land is used, and with also things like climate change or rising sea level and many other things, we see that less and less land is going to be available to meet different, in fact, our growing demands too, with our growing population and other things. So what it means to us is that we want to look how these different demands might induce land cover changes, and given that land is scarce, these land cover changes will almost have an impact that will come as a trade-off between different services. So if you replace forests by crops, you're going to tend to lose carbon sequestration for crops, for instance. And so two aspects that are important, and a very important aspect to us is the regionalization of these land uses. And given the globalization of markets and production system, we can see in the life cycle of a product, land use occur potentially everywhere around the globe. And in fact, their impact on ecosystem services depend on where they happen. So with that in mind, what we first did was a review of existing models. So it's a work we published in 2016. And what we mostly saw, the main results of the review were that current models don't, in fact, model land cover changes. So current methodologies have a slightly different approach, which I'm not going to go in the detail of, but we can discuss later. We also observe that they usually tend to model ecosystem services independently from each other, while there are in fact important dependencies among some functions, ecosystem functions. And also, they tended not to consider landscape effects, that is, in fact, how the different configuration of land can differently support the provision of some services. And also, they didn't consider, most of them did not consider the whole value chain of ecosystem services, that is, from the functionality of ecosystem to valuing the benefits they provide. They tended to do that in a step-by-step approach. And finally, it seems, given how different land use is and how you get different information along the life cycle on land use, it seems interesting to develop the approaches to assess ecosystem services at different scales. So, to assess this impact, just to clarify, if we think of the DeepSeer framework, so the DeepSeer framework is a much used conceptual framework to assess impacts. It's reference for European Union and UN too, I think. I mean, many people use it. So what it does, it considers a driver, which in LCA will be the functional unit, the production system you study. This driver is going to cause pressures. So as a pressure, we consider land use, and potentially the land cover and is going to be a pressure that's going to induce land cover changes. So these land cover changes are going to impact the state of land covers, which is to us proxies for ecosystems, in fact. And these changes in ecosystems affect the functionality of ecosystems, the services they provide. And so as an impact indicator, we want to consider the change in provision of ecosystem services so that later it can be interpreted. And so in our case, it means we developed models. So to consider the land use induced by the production system, we already have a life cycle inventory method. So that's the step we take for granted. And what we wanted to develop are characterization factors, which are in fact meant to approximate an integrated model which we developed and which is based on the coupling of a land cover change model, ecological models, and ecosystem services valuation model. And then these results can later be used in the life cycle impact assessment stage of LCA, as Benedetto introduced earlier. So out of this, what we did is we developed two models. We developed a model first at the scale of Luxembourg. And in this model, we focused on pollination and carbon sequestration as main services, focused services. We focused mainly on two services, pollination and sequestration, but we also looked at other ones. And so this one I'm going to present you right after. And then we developed a global scale model, which I will come back to it in the end, is more oriented toward understanding the contribution of land and by extension ecosystem services to the overall well-being of society, let's say, and development in general. And so at the scale of Luxembourg, we basically coupled the three models. So we have, first, considering the structure of mines in general, what we are interested in is looking at the different interactions between society and its well-being and how society makes decisions to use land and how this use of land can constrain ecosystems and their production of services, and hopefully understand how these changes in the productivity ecosystem can affect back society's well-being. And so to do that, we couple different systems within following the MIMES overall framework. So to model land cover changes, we use the CLUES model, which is a cellular automata. I will show you results after. For the valuation of ecosystem services, we conducted a monetary valuation, and the results it provides come down to evaluating the opportunity cost of land cover changes. And to understand how land affects the production of ecosystems, we considered for pollination the INVEST model, for carbon sequestration the biome model, and different proxies to assess other services. These proxies mostly come from the MAES study that was conducted for Luxembourg, which will be presented later by Stefan from Space for Environment, who conducted this study, and was in fact a great source of data for us. So yeah, so now I'm going to let the place to Marco Bayer, who is going to talk about pollination in Luxembourg.